Problem 37. So in DNA is made up of 4 sequences of the molecules A, G, C, T, and we call a bases. They are called a bases. So we have 4 bases A, G, C, and T. A codon is a sequence of 3 bases. So for example, we have like AAA or CGC and so forth. Codons are important because each codon causes a different protein to be created. Per A, how many different codons are there? So again, to make a codon, it is a sequence of 3 bases. So here is a codon, 1, 2, 3, and for the first one, it can be base A, can be base G, can be base C, or can be base D. So we have 4 choices for the first one. The second one is the same. It can be A, G, C, or T because it can be repeated just like AAA can be repeated. So we have 4, and similarly for the last base. So we have 4 choices. So we got 64. For part B, how many different codons are there in which all 3 bases are different? So to get a codon, we need 3 bases. And the first codon, we have 4 choices. And the second one, the first base is 4 choices. The second base can be anything but not the first one. So we have 3 left. And then we have 2 gone already, so we have 2 left out of 4. So 4 times 3 times 2 is giving us 24. In problem C, A and G are called purines and C and T are called pyrimidines. How many different codons are there in which the first base is the purine, the second and the third is pyrimidines? Okay, so we have a codon 1, 2, 3. The first one must be the purine, and the purine. Yeah, for the purine, we have 2 kinds of purine, A or G, so that is 2 choices. The second one they says it can be purine or the third one is can be purine also. Sorry, the second one and the third one is pyrimidine. So we have 2 choices, is COT and COT for the third one. So that is 8. What is the probability that all 3 bases are different? So you notice that in part D, they're asking us to find the probability, and part E are also the same. In part A and part B and also part C, they're asking you how many. So to find the probability have to be in a fraction. The bottom is have to be a total, and the top one is the number of the event. So the total codon that we have is 64. This is from part A. Okay, and we find the probability that all 3 bases are different. That will be in part B. We know that the number of the different bases, different codons have different bases is 24. So 24 out of 64. In problem E, we know that the total codons we have is 64. And we want to know the probability of the first one is the purine, the second one and the third one is pyrimidine. So that is part C, right? Because we already count in part C that we have 8 different codons that has the first base is the purine and the second and the third is the pyrimidines. So that is 8 out of 64. So for the probability, you use a calculator to divide and take 3 decimal places.